Now we will activate and set up our virtual environment. To set up the virtual environment, we are using the venv, which will help us to create a virtual environment for this project. So I'm just copying the first command, going back to the terminal, pasting here. To validate that virtual environment is created or not, we have to run the ls command, and this kfp env is our virtual environment. Now whatever we will install, those will be gone into this directory only. This is the command to activate this virtual environment. This prefix will clearly tell us like our virtual environment is activated now, and now we will install the different libraries one by one. So I will execute multiple commands one by one, and it may take some time to run successfully. So our next command is to install the Python with version 3.0.0, and our next command is to install the py.yaml, pressing enter. This is our second last command, pressing enter. This is our last command to install the kfp with version 181. It executed successfully, and our all the required libraries are installed successfully. Now I'm going back to the readme.txt file, and in the readme.txt file you can clearly see the ice cream price prediction pipeline. We have to run it via the Kubeflow, and this is the directory structure of the ice cream price prediction. And here we have couple of directories. Like one directory is the components. Inside this we have the preprocess.py. It will help us to clean and prepare the data. It will read the data, it will do the pre-processing part, and you can modify this script as per your convenience or as per your data or the problem statement. Then we will run the train.py file, and inside this train.py we pick the model and we train it with this available data. Then in the evaluation.py file we write a script to evaluate our trained model onto the test data, and then the deploy.py, this is the optional one, and we are taking help here to deploy the model with the kserv part. And another directory is the data, and our all the data files are available in it. So in my scenario I am using the ice cream.csv file. This is the raw data set for training the model. And notebook directories I have. Inside this notebook directory we have run pipeline.ipynb, and this notebook will help us to execute the pre-process train and the model evaluation part. We will run this notebook via the Kubeflow so that those experiments and other stuff may be visible into the Kubeflow UI. And utils have the client.py file, and we are using client.py file to connect Kubeflow Pipelines API. And in the MLpipeline.py file we defined all the codes to run the successfully or the sequentially these components like pre-process, train and model evaluate. And then this ice cream pipeline.yaml will be a compiled pipeline, and it is auto generated by the MLpipeline.py file. And another file we have a docker file you can clearly open, and it's a very small file in which we are taking the base image for the components for the different like for the pre-processing, for the training and for the evaluation one. And in the readme.md file we describe whatever steps we have to execute and what sort of process we have to follow. Okay, so I came to the Visual Studio Code, and here you can see my code available in the ice cream pipeline directory. I'm opening it, and we have multiple directories in it. First of all, the components. Inside it we have multiple components. First of all, we have the preprocess.py. We are just reading the data here and generating the data frame with the help of pandas library. and we are defining the output CSV path, which is coming from the pipeline ML pipeline.py, whatever the location we are passing in the pre-process component, that there we will store this data frame. So after running this component, we will print this function, and this is the model training pipeline, and we are writing a parent function here as a train, and multiple import statements are there, pandas to read and to play with the data, and joblib is we are using to create the model pickle file, and MLflow we are using to store or to visualize the experiments about the model version and other stuff. And then the sklearn linear model we are using because we will resolve this problem statement with the help of linear regression. And the model selection part we are using to split our data into the test and train. So there are some global variables we have to define. So I hard coded it for myself, and you can tweak the code, and you can directly pick it from the environment variable, or you can pass it via the functions argument or the parameters. So MLflow.set tracking URI will be this, and my MLflow is running onto the 32,000 port, and you can replace it, or you can update its value. And I'm saying like my experiment pipeline name should be the ice cream pipeline. And now I will read the data from the input CSV path, and then we will divide or we will separate out the feature and the labels of the data set, and then with the help of train test split we will split the data into train and test part, and later part we will create instance of the linear regression model, and the next line will train the model. With this line of code we will save the model file, or you can say the dump the model file or the pickle file of the model. And then this piece of code we can say like it will help us to generate the artifacts into the MLflow part, or it will generate the logs into the MLflow one. So this will be the final print statement. And coming to the evaluate.py, the same sort of variable required here, and we have to set tracking URI, set experiments, and then we will load the model which we dump into the train.py file, and then we will generate the prediction, and based on those predictions and the actuals available with us, we will figure out the mean absolute error and mean squared error and the RMSE and the R2 square. So you can update these parameters or the matrices according to your model or the problem statement, and then we will generate a dictionary to store all these model evaluation metrics, and then later part we will dump these metrics at the location of the data and the evaluation.json part. So again these are the log matrices which we have to log into the MLflow one. So this was about the model training and model evaluation part to log all the matrices to the MLflow part only. So coming to the ML pipeline.py code, and you can see here we have a couple of import statements, and the DSL is helping, and we are importing from the KFP, which is the Kubeflow pipeline only. And we are saying the pipeline name will be ice cream pipeline, and the description will be this. You can update according to your scenario. And later part we will define ice cream pipeline function, and inside this we are saying like test size will be 0.2 and the random state is the int 42, and this is again parameters. You can update the size of the test data, you can update the random state parameter. And then later part we can say like the pre-process step will be the first step here, and to pre-process step we have to execute like the output CSV path will be this. Whatever the pre-processing we are doing, after performing the pre-processing steps, the output will be stored at the /data location with the file name ice cream clean.csv file. And then we are saying like pre-process step.add p volume. What it means is it will be added as a component into the Kubeflow volume. And our next step is to the train, and in the train part we are again saying like that this is the input path which we stored onto the previous component as a pre-processed data. And after executing the pre-processing part, we have to store the model. So this is the location where the model will be stored, and this after method will help us to say like once the pre-process is complete successfully, then we have to execute it. So it run into the synchronous manner, or the you can say the sequentially. Once the pre-process is completed, then the training part will come into the picture. And our next step and the final step is the evaluation. The same way we are storing the model path, we are storing the input CSV path, and we have to execute this step after the train step. Once the evaluation is ready, then we can add via the add p volume, and this is the location where we will store all the matrices, all the parameters, all the metrics. And train.step .p volume is there. KFP compiler, we have to import the compiler, and then compiler.compile, and then we can pass the ice cream pipeline and its YAML file, and which is created via the MLpipeline.py file. And this same file will be available into this directory or the parallel to the MLpipeline.py file. And this util folder we have inside the client.py file, we define the import KFP and the get KFP client to connect with the Kubeflow client. We are providing the host URL, and we are just returning it via the kfp.client, and host is equals to host URL. You can directly pass this static value instead of the host URL. We are trying to make it dynamic, and you can replace it according to your IP and port 1. So let me show you the data. So we have only two features into the data. One is the label, and which is the price one, which we have to predict according to the temperature. If the temperature goes up, the ice cream sale will automatically increase and the price will automatically increase. So this is the demand supply game. If the demand is increasing, then the price will automatically increase, or the sale out or the consumption price is increased. And coming to the notebooks part, so run pipeline.py file. So we have a couple of cells in this notebook, and you can see the we have import statement for the OS and the system to get the access of the system and the operating system, to get the actual directory paths with the help of this one. You can adjust it according to your path, and this if statement is available here to just append with the current directory with the any static path. And the utils.client is get KFP client. We are importing get KFP client from the client.py file, and we are generating an instance of the client. Now we have to run the next cell, which is the client.upload pipeline, which is the pipeline package path is this one, and which will create automatically just parallel to the MLpipeline.py. And once this starts executing, and our pipeline name will be ice cream pipeline, and you can change this name according to your convenience. And you can not change this path, because in the end-to-end scenario this YAML file will be automatically generated by the code which we write here. And coming to the next cell, so it is saying like client.create run from pipeline package, which is saying the pipeline files, and this is the YAML file. Arguments we are passing as a blank, and you can pass the different arguments which you can make it dynamic for the YAML file. And the run name will be looks like the ice cream -run. And these are the notebooks which we have to take care. So I am going to the terminal to show you how we can execute the this pipeline, or how we can compile it. I am just clearing my window and increasing a size bit. Now we have to run the Python. So there is a MLpipeline.py file, and we have to run it. via the Python. Pressing enter. Again running the ls command to see the YAML file is there or not, and you can see clearly the YAML file is already available. Now I will go into this notebook directories and run this notebook which I showed you earlier and which I explained you. So I opened it in my Visual Studio Code, and I will run it one by one, cell by cell. So coming to the Visual Studio Code, I opened this notebook file in my Visual Studio Code, and you can see here, and I can directly run it via this icon. So I'm running it. It will execute into the node machine which I am using. So it ran successfully. Our next cell is this one. So we have to set up all the virtual environments in our node machine. So I am using this extension to access the node machine's code. So I just opened the folder here, and I select the kernel as a KFP environment which we created as a virtual environment, and to use this environment we have to just click here and select the available virtual environment, which is the KFP env, and now I will start running the cells one by one. So let me run first cell. I get this error. To overcome this error, we can run this command and just copy it, and just I'm pasting it into the terminal and pressing enter. So it is saying like I don't have permission to this directory, so we have to give the permission, and so again it is giving me the permission error. To resolve this error, I ran it the sudo su, and later part I ran this command source kfp, and I activated the virtual environment which we are taking as a kernel for this notebook, and again copying this command and pasting here, and you can clearly see it ran successfully at the bottom now. And now we can retry to execute this cell. So you can clearly see it ran successfully. Now our next cell is this, so we have to run it. Now we have to run the upload pipeline. Once we are uploading this pipeline, and we can go to the Kubeflow and clearly see the pipeline should be there, and I already opened in my browser, and I have to just refresh the page and go into the pipelines, and you can see the ice cream pipeline is available, and whatever the name we provide here, that will reflect into the pipelines, and you can see, you can type a name like test abc xyz according to your preference, and now we can click on this expand icon, and you can clearly see the version name and description and other stuff. It ran right away at the 9:51 p.m. of the 6/24 of 25. You can clearly see it ran a couple of seconds back, and our next cell is to execute create run from pipeline package, and let me run this cell as well, and what it will do, it will show the experiments to us, and inside the experiments we can open the default part, and we can clearly see ice cream run, which is the similar to this name. You can update this name and try it on your own self, and I'm just clicking on it to show you the pipeline, and after clicking on that icon, you can see this create volume is ran successfully, and now pre-process is in progress. It will take some time, and I'm clicking on the pre-process part now, and it will show you all the input output visualizations and details, volumes, logs, pod, events, ML metadata, what sort of metadata it is generating for this run. So it will take some time to execute the pre-process and then model train and then the model evaluate part, and this graph will automatically updated. And I am pausing this video till this process executed successfully. I will come back once it is finished. Yeah, it took more than expected time because the configuration of my machine was on a lower side. So you can clearly see the create volume is available, pre-process ran successfully, train ran successfully, and evaluate as well. So we can select a particular job and go into the logs part, what sort of logs we have generated. And I'm going into the pre-process part, and whatever the print statement we described, that is clearly visible in this. Same for the training as well, and we can see like the created version 1. So whenever we will re-execute this pipeline, so the next version will be created for the same pipeline and for the same model. And for the evaluate part, you can clearly see the evaluation, whatever the print statement we define into the evaluate.py, that is visible here as well. So you can go into the volumes, you can go into the details, visualize, and input outputs as well to just check what type of things we have in it. So in the evaluate part, as we describe, like mean squared error, and what is the value of it, and what are the other metrics like RMSE and R2 square and other stuff. So the same way we can go into the MLflow part, and we can clearly see the ice cream pipeline is available there. And this is the execution which we ran 10 minutes ago, and I'm just clicking on it, and inside it we can see like it is finished with the green icon. And this is the ice cream model pipeline version 1. And to see the metrics of this model, we can go into this part, and to see the model artifacts, we can click on to the artifacts, and click on this models part, and we can see this is the model file available here. And this model file is available into the S3. This is not related to the AWS, this is related to the my node, as we worked on to the min IO part. And in the min IO part, that is the object storage sort of thing, and it will store all the model artifacts on this location. Now I'm going into the models of the MLflow, and we can see the version 1 is available here, which is trained a couple of minutes back. And I'm clicking on this one, and it will show you the version. Now you can add tag, you can add aliases according to your convenience, and you can open the description part, you can open the tags one if there are any. So now I'm coming back to the experiments, and opening this the latest execution, and scrolling up down, and you can see the model type is linear regression. Input data was available onto this directory, and we pick the sklearn model here of the linear regression part. And yeah, all the matrices, all the artifacts are available and clearly visible into the MLflow. And we can see the end-to-end pipeline executed via the Kubeflow. And yeah, this was it for our practical session. Thank you so much for watching, and just comment us or reach out to us if you have any queries.